Assalamualaikum warahmatullahi wabarakatuh and good morning. So in this video I will discuss question number 13, 14 and hopefully question number 15 as well. So the first question number 13, they ask you to find the force on wire PS. So you will have a force over here due to this wire. Okay, you have two force, so you have two current that is moving in opposite direction like this. So straight away you know that this one is actually a repulsive force. So to solve this one, you can use this one formula, F over L over mu naught I over 2 pi d. This one is formula for force on two current carrying conductor. So they want to find force, so I can solve it straight away. So mu naught is actually equals to 4 pi times 10 negative 7. Okay, we are talking about this I, so it doesn't matter which one you put, but I just put this one correctly. So 3 and 6. Then the distance between them is actually 3 cm. So maybe I change straight away to meter. Don't forget about the L over there. So I think I'm going to bring this one a little bit further here and multiply with L on the right hand side. So the length of the wire here is 0.11 meter. Now you just have to press the calculator. I mean, if you want to quickly press, I think you can cancel out the 2 pi and 4 pi first. I got his F equals to 1.32 times 10 negative 5 Newton. Okay, so because this is a repulsive force, therefore the direction is on the wire of PS, it is to the right. Okay, if you're talking about on this wire X, it is to the left, but in this case for wire PS, it is to the right. Okay, next question B. If you want to find the force on wire QR, okay, again you can use the same formula. So I'm just gonna copy this one, bring it down there. Okay. So again, we want to find the force. Will be, okay, there's this same current over here, so it will be 3. So the distance now, you need to use the distance from here to here. Okay, will be 7 cm, which is 0.07, and the length is 0.11. Okay. I got here is 5.65 and 5.66. Okay, and then here you have the current that is actually moving in the same direction here. So as a result, the force will be attractive force. So this one is actually attractive force. Okay, so the actual direction in here is to the left. Okay. And for question C, they want to find the resultant force on PQRS. So the force only apply on the parallel current carrying conductor, which is on here and on there. So if I want to find the net force, basically I have to combine both force. So I have one force that is this one, attract, this one, repulsive. So let's say I put this one as my F1 and this one as my F2. So if I want to calculate F net, or maybe FPQRS, maybe I change this one to the different subscript. So FPS and FQR. So it will be right minus left. So PS just now I got 1.32 times 75. 5.66. Okay, here I got 7.54 times the negative 6. Okay, because this one is positive, so you expect the direction to be to the right. So every single time you determine the direction of, every single time you determine the force, you need to determine the direction. Okay, and don't forget to write the unit. Okay, question number 14, they ask you to find the torque acting on the loop. So the question is to find the torque acting on the loop. This is the question. You are given a circular loop, current 2 ampere, radius 10 cm. One is perpendicular, another one is parallel. But you have to read carefully whether this one is the plane or it is the vector itself. Okay, so logically we want to use this formula, torque equals to NIAB sine theta, but the theta is actually the angle between vector A and B. So B is basically just the magnetic field punya direction. In this case I put both of these in the same direction. Okay, one circular loop is the plane itself is perpendicular to the field. So this is the plane. Okay, it is perpendicular to the field, which is 90 degrees. Okay, this one, the plane is parallel to the field. Oh, sorry. So the plane is in the same direction with the field lah. One is parallel and one is perpendicular. But if you want to use theta here, the theta would be from the vector A. Vector A is 90 degrees from the surface. So I change to red color instead. So this is my A. It should be 90 degrees to the plane. Okay, so you have to read carefully. The question normally they will give you direction of plane, which is this one. And the vector is 90 degrees to that plane. Okay, now you can use the formula. That's my pen. Okay. So if you want to solve the first question, torque equals to NIAB. In this case it will be sine 0 degree, because direction of magnetic field, which is in this direction, is in the same direction with the area punya direction. Okay, so equals to 0, because sine theta is equals to 0. Sine 0 is equal to 0. The second question, this one you will have a value. So torque equals to N is equals to 1, I is equals to 2, A you can calculate pi r square, so 0.1. So I change to meter as well, and B is equals to 0.5. Again I have to bring this one a little bit to the left, and it will be sine 90 degrees, which is equals to 1. Okay, here I've got 0.0314, so it will be 3.14 times 10 negative 2 Newton meter. Okay. For question 15, you have question A and question B, but I think question A you can do it yourself. That one you can refer to your notes on internet. Okay, for question B, in a mass spectrometer, a singly ionized molecule moves at a speed of 7 on a circular path has a radius of 15 cm. So you will expect mass spectrometer something like that, right? So you have molecules that's moving in that direction. If the spectrometer uses magnetic field of 0.15 Tesla, calculate the mass of the molecule. So the important things about mass spectrometer is that it uses a concept of Fc equals to Fb. Fb equals to Fc, I write in this way. So Fc is equals to mv squared over r, everyone know this. And Fb is actually equals to qvb. Okay, it is actually qvb sine theta, but it is always 90 degrees. So if you want to find the mass, you can cancel out the v. So it will be rqb over v. Okay. The radius is given 0.15. The charge here is actually dependent on the term here, singly ionized molecule. Single ionized molecule could be -1 or +1, but the charge is 1 charge, which is 1 E. So I'm gonna write just 1.6 times 10 between 19. Magnetic field is equals to 0.15, and my velocity is actually equal to 7.6. I got here 4.74 times 10 to the negative 25 kilogram. I'll double check the answer. Okay, so that's it. Thank you.